Okay, so we've talked about the domain of a rational function and the vertical asymptote of a rational function. So what we need to now talk about are horizontal or slant asymptotes. These are the final two asymptotes that you might have occurring in your rational function. If you read right here, you'll see that there is a series of things that we can use to identify whether or not my rational functions has asymptotes that are horizontal or slant. And it really, this is what we're going to use to identify what we're talking about, what type of horizontal versus slant asymptote we're talking about, and it's going to be much easier when we can just dive right into it. You can see that we're going to do that by evaluating the degree of the numerator versus the degree of the denominator. So I encourage you to write this down real quick, maybe pause the video, and then we'll move on. So I'm going to find either the horizontal or the slant asymptote of these four examples that you see listed down here. Now, one thing to note, if I cannot have both horizontal and slant asymptotes. You have either one or the other. I can have a horizontal and a vertical asymptote, or a slant and a vertical asymptote, but I will never have a horizontal and a slant asymptote. So if this is my first rational function, x minus 12 divided by 4x squared plus x plus 1, what we're going to do is we're going to evaluate the degree of the numerator and the degree of the denominator. So remember, we do that by looking at the highest power of my polynomial function, and we want to look at that in its descending order. So this is already written in descending order. This has a degree of 1 for the numerator, and in the denominator I have a degree of 2. Well, 1 is obviously less than 2, and because the degree of the numerator is less than the degree of the denominator, I'm going to scroll back up here for a second. If the degree of the numerator is less than the denominator, we have a horizontal asymptote occurring at y is equal to 0. So that just tells me that's my asymptote. So we're just evaluating the numerator versus the denominator to determine what our asymptote is. Okay, let's look at another example. Here I have 3x to the 4th minus x squared divided by x cubed minus x squared plus 1. So the degree of the numerator is 4. The degree of the denominator is 3. 4 is greater than 3 by just one more, right? 4 is one more than 3. So if the numerator degree is greater than the denominator by one more degree, we have a slant asymptote. Now, what we're going to have to do if we have a slant asymptote is, so I have a slant asymptote, and I'm going to have to use long division in order to be able to find out the equation of the line that is slanted. Now remember, we're going to be looking for a slanted line, and that is actually our good old y is equal to mx plus b. That's the equation of a line that is has a slope of m, right? It's slanted. So we're going to use long division to come up with this answer. When I do that, remember, I'm going to take the denominator here, x cubed minus x squared plus 1, divided into the numerator, 3x to the 4th. I'm going to put in an x cubed plus 0x cubed minus x squared, just to hold my place on this one. We've done this before, but let me just remind you. I'm looking at what do I multiply x cubed by to turn it into 3x to the 4th? Well, that would be 3x. So don't forget, when we do long division, we now multiply this number by all three of these terms. Let me get rid of that line. So this is going to become 3x times x cubed, which would be 3x to the 4th, minus 3x cubed plus 3x. So plus 3x. I got to line up my x over here because it's not a squared. Now we got to go in and we're going to change our signs. and then add straight down. So this is gone. This is now a 3x cubed. Bring down my x squared and minus 3x, and we start all over. So what do I multiply x cubed by to get 3x cubed? Well, that's plus 3. So 3 times 3x cubed is, again, 3x cubed minus 3x squared plus 3. Okay, so we're going to change our signs, and as long as that disappears, we're good. We could keep going, and you remember that if I kept going, I could come up with the remainder or keep, something like that. I actually don't have to, because notice that right here I have, and let me erase that for a second. What I have is 3x plus 3. This is the equation of a line that has a slope of 3 and a y-intercept at 3 also. So in other words, this is the slant asymptote. All slant asymptotes will end up being the equation of a line. Okay? And that's how we do this one. Now, let's look at this rational function here. In this case, again, we're going to go ahead and we're going to talk about the degree of the numerator, which is a 2, the degree of the denominator, which is also a 2. Now, whenever the degrees are equal, we have a horizontal asymptote, and we're going to come back and we're going to use these leading coefficients right here to find out what the equation of my horizontal line is. So 8 divided by 4 equals 2, and therefore the horizontal asymptote is y is equal to 2. I mean, it's pretty easy as long as you see what to do first. So I have a horizontal asymptote at 2 here when the degrees of my numerators were the same. Now the last example we're going to look at is this one right here. This one says that the degree of my numerator is 5. The degree of the denominator is 3. 5 is greater than 3, but 5 is 2 more than 3. So I don't have a slant asymptote. Remember, that was this one up here. When my numerator was greater than my denominator by only 1 more, then I had a slant asymptote. This is greater than my denominator by 2 more, but that's not going to give me a slant asymptote. And that actually, there is no horizontal or slant asymptote occurring here. Actually, what's occurring is, let me just take this for a second and let's do long division on it really quick. X cubed minus 1, and then if I have 2x to the 5th minus x cubed plus 2. Remember, when we do long division, we say, well, what do I multiply this by to turn it into this? That would be 2x squared, and I'm going to stop you right there. Because if I come up with a function that has a squared term in it like this, remember that's a quadratic, right? That's a curve. And all of my asymptotes that I'm looking at are lines. They're either vertical lines, horizontal lines, or slanted lines. And in this case, this is not a line at all, it's a curve. And that's how come when the numerator is greater than the denominator by 2 or more, there is no horizontal asymptote. So the criteria that you're going to be using is based on these 4 criteria right here, and that's what you're going to use to find either a horizontal or a slant asymptote.